Okay, last video introduced hydrolysis of acetals. Now I'm going to do imines and enamines. Actually, not that bad. Okay, we're going to use the same concepts. Okay, what makes a good leaving group? Positive charge. Hydrolysis means water attacks, and we should be able to predict our products off the start. So let's start with an imine, carbon double bond to a nitrogen. We can make up any type of imine we want, it'll work out. Okay, so when you're working with a friend, or you can even do it on your own, test yourself. You can write any imine you want. We know that hydrolysis, we're going to use water, and we should be able to predict our final product. What should our final product look like? Or what should our final products look like? I should have a ketone. I just replaced that with an oxygen. And then I should have a primary amine. Boom. Okay. Amines work under mildly acidic conditions. Those aren't going to change. It's reversible under the same conditions. All the same as before. Before we were going from this to that, and we remember water left. Now we're using the water that left and what we made to go in the reverse direction. So I'm going to try and use double barbed arrows. If I don't, I'm just giving you a heads up, I might not. Also try and count carbons and such. So that's what we should expect at the end. A ketone and primary amine. Blah, 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 blah. I should have left those up there. But if I notice my product, I needed a ketone, right? I need nitrogen to leave. What makes nitrogen a good leaving group or a better leaving group? What makes anything a better leaving group? Giving it positive charge, okay? So I'm mildly acidic. Let me use H3O+. Lone pair on nitrogen. I'm going to get lazy with this step. There's a more accurate way I could draw it with the bond going on to oxygen. Ta-da. And then water. Okay. I've made my positive group there, good leaving group. Okay. It's not going to really leave, but we'll get into that. This is more of an activation. It'll leave with positive charge in a bit. Okay, we're still going to protonate it here though. Okay. Water. This is going to be our hydrolysis step. Bond up on nitrogen. Okay. So I shouldn't have said that was really a leaving group step. It'll work the same way though. Give nitrogen positive charge. To keep that, give nitrogen positive charge. You're going to get pretty far on these reactions with that alone. Sweet. I have a charge in my molecule and it's due to protons, either an excess or I don't have enough. So proton transfer. H2O, take a proton off. Oh, I forgot the hydrogen. Oops, forgot to carry that over. Okay. Blah, 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 blah. H group now, like that. All right. Now, it's the same as before. It's the same as the acetals. There's really no difference. I want a carbon-oxygen double bond in my final product with my ketone, and I want my primary amine to leave. How am I going to do that? How am I going to form a carbon-oxygen double bond and allow our amine to leave? Okay, I would use this to create a double bond. But what makes a better leaving group? Let me protonate this first. Let's give nitrogen a proton first, then let it leave. We don't want N- floating around in our solution. So to give something a proton, let's use H3O plus again. And I'm going to get lazy and just draw that. Now it's protonated. Now it's a good leaving group. So I don't want water to leave on its own. I need something, for example, I don't ever want leaving group rules. I don't want water to leave by itself. I want to initiate that. I really want to initiate any leaving group to leave. And I can better that leaving group by giving it a positive charge. Listen to that a couple of times. That was well put on my part. Oh gosh, that's a plus. And look at this. Nearly exact, what we predicted. I just gotta take this proton off. What am I gonna use that? Water. I'll use water. I'll regenerate H3O plus. Acid catalyzed reaction. Yeah. Okay. So take a proton off, water, blah, 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 move it up, blah, 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 or ketone. Proton transfer. Tired of these things. Ta-da. And it's exactly what we predicted. Was there much different at all between this hydrolysis and acetal? Not really. Okay. What makes a good leaving group? Positive charge. How do I kick off a leaving group? Make a double bond. What should my product look like? Am I getting closer to my product? Okay. All right. If that didn't make sense, watch it again.